Alrighty, so today we're going to be once again converting from form to form, and in this case we want to get to root form. So what if we have the general form, or if we have the turning point form, can we make them look like the root form? And in order to do that, we just factorize. So let's look at the first one. The first one's clearly got a factor of 3 at the front. In fact, I'm going to take out negative 3. Now it's going to leave me with x squared minus 2x minus 6. Again, you can just check by expanding the brackets. Oh, not 6. It'll be minus 8. Alrighty, and you can check by expanding the brackets to make sure that that works out. And now from here, I'm going to try to factorize the inside bit by using a t-chart. So I'm looking for two numbers that multiply to negative 8 and add to negative 2. It could be negative 1 times 8 or negative 8 times 1, but they both add up to 7 and negative 7 each. It could be negative 2 times 4, but that adds up to 2, or it could be negative 4 times 2, which does add up to negative 2. So we know which one it has to be. It has to be negative 4 and 2. So I'm going to decompose in the middle here. So we're going to get y is equal to negative 3 x squared minus 4x plus 2x minus 8. Notice we haven't changed it because minus 4x plus 2x is still equal to negative 2x. Now I'm going to do my bit by bit factorizing. So factorize these two together, factorize these two together. X minus 4, 2x minus 4. Oh, common factor of x minus 4, leftovers of x plus 2. And my factorized form is minus 3 x minus 4 x plus 2. And there we go, all finished. So for the second one, if you've got it in turning point, well, turning point's a little bit different. It's not written in general form, so you cannot factorize it simply. So instead what you do is you expand the bracket so it is in general form, and then you factorize it. So let's start off by expanding this out. So we get y is equal to, y equals 3x minus 5, x minus 5, minus 3. Expand the brackets, we get y is equal to 3, x squared minus 5x minus 5x plus 25 minus 3. We then get 3x squared minus 10x plus 25 minus 3. Expand the next set of brackets. 3x squared minus 30x plus 75 minus 3. 3x squared minus 30x. And then 35 minus 3 is 72. All of these are multiples of 3, so let's factorize out the 3 out the front now, because now we want to factorize the whole thing. So it's going to be 10x, 72 divided by 3, 4. Y is equal to 3. Oh, okay, well, now we need to decompose this because this is ready. So let's get our t-chart ready. Times to 24 times 1, which is 24, adds to negative 10. Could be 24 times 1. It's going to have to be negative both because it's going to add up to a negative. It could be negative 12 times negative 2. It could be negative 6 times, negative 4. And that's the one that works. The first one adds up to negative 25, the second one adds up to negative 14, and this one adds up to negative 10. So we're going to decompose like so. We get x squared minus 6x minus 4x plus 24. Factorize bit by bit. Once again, be conscious of signs. So x minus 6, so I want the other one to have x minus 6, so I'm going to take out negative 4 here. It's going to leave me with x minus 6. If I didn't take out the minus with it, if I took out just positive 4, I would be left with minus x plus 6. And you see that that doesn't match. So if that ever happens, it's a good reason that you need to think about maybe taking out a negative factor as well. So negative 4 comes out, we're left with x minus 6. Now it's all looking like it's going to work out because we've got these two are matching. The leftovers is x minus 4. And that leaves us with y is equal to 3, x minus 6, x minus 4. And we have factorized it into root form. Advantage of root form, I know that this one's x-intercepts are 4 and negative 2. And I know that this one's is 6 and 4. So this is the reason why factorizing is really useful, because it means you can quickly look at the roots of a function. Worst case scenario, you can always use the quadratic formula. Alrighty, see you in the next one. Goodbye.